Hello there. In this lesson we will be going through the Mathematics Extension 1 syllabus for the HSC. The purpose of the syllabus is to outline the course, what you will be studying and any prior knowledge you need. It's also intending to give the rationale of why you are studying what you are studying. The introduction to the syllabus outlines the purpose. We've got 6 dot points here, and they all give some applications which you will find from your study of the Mathematics Extension 1 syllabus. You can read through these on your own, but I will just emphasize the application you will find in STEM areas, because these are the areas of the future of the workforce. Hence, in your study of the Extension 1 course, you will develop skills in problem solving and other mathematical techniques, which will help you in the future if you wanted to get into the STEM industry or any of the other industries outlined here. The purpose of the syllabus is elaborated later in the aim. The outcome coding is a convenient way of indicating which outcome each topic is addressing. When we read the subtopics, we will be able to see where outcomes overlap and what the syllabus is intending to achieve. However, I wouldn't pay too much attention to the coding or the numbers. You will get more out of actually seeing the content yourself, which we'll get to later. The rationale of the syllabus is a rehash of the introduction. It is saying why we are studying this, what we want to get out of it. In the 4th paragraph, it acknowledges that through the study of HSC mathematics, you will develop a particular set of knowledge and skills. This set is further developed in the Extension 1 course, and it will help you in the real world, particularly in those aforementioned industries. I will also pay some attention to this last paragraph, of how it can provide a basis for further study of mathematics or other areas which involve mathematics. These are areas of science, engineering, finance, and economics, so those STEM fields, as well as some other areas. So if you are intending to select the Extension 1 syllabus, keep in mind what you want to study after school, because it will help you and prepare you for the real world and those other industries. Here we can see the transition from Year 11 to Year 12 in terms of the mathematics courses. As this is Extension 1, we will be paying attention to this second from the bottom component. As you can see, in Year 11 you would have studied both the Advanced and Extension 1 courses, and those add up to a total of 180 indicative classwork hours. In Year 12, you will be studying the Extension 1 course, as well as the Advanced course, and you will again be studying 180 indicative hours. You will know that these add up to 3 units of mathematics. That means of the 10 units you need to get your HSC, you will get 3 from mathematics. While we are talking about the units, I would just like to emphasize that you should be doing more work for your mathematics as compared to your 2-unit subjects, because in the end it will be worth an additional unit towards your HSC. This page is another graphical representation of the transitions from your beginning of mathematics and school to your final years of mathematics in stage 6. You can see that you have moved through the different stages and you are now at the end point. In particular, you are here at Mathematics Extension 1 as well as Mathematics Advanced. Another key bit, which they seem to be emphasizing a lot throughout the syllabus, is that they show how you can get from this stage, or even the stage 5 mathematics, into outer education. So here we have the aim. This is a more in-depth purpose of the syllabus. So it enables you to extend your knowledge and understanding of what it means to work mathematically, to develop your skills to reason logically, to generalize and make connections, and to enhance your understanding of how to communicate in a concise and systematic manner. So these aspects will all be talked about more later in the working mathematically component of the syllabus. However, I would just like to pay attention to how, since the content is harder than Mathematics Advanced, you will develop more skills and you will understand more mathematical knowledge. This will not only help you in mathematics, but it will also be something which is applicable to your other subjects, as you can apply these tools of reason to do well in everything. We will also be able to structure our responses and communicate well, another transferable skill to other areas. The outcomes is something you can read through yourself, and it will be popping up across the different topics, but it just outlines what we will achieve through our study of the Mathematics Extension 1 course. This page gives a visual illustration of the topics. You will notice that all of the mathematics you do in Year 11 and 12 is underpinned by 6 key aspects. These are the aspects of working mathematically. This illustration highlights that in order to do well in maths, all you need is to excel in these 6 areas: understanding, fluency, communicating, problem solving, reasoning, and justification. And we'll get to these now. The Working Mathematically section gives a good insight into how to address questions through these 6 areas. We can use this to work backwards, and hence determine which questions they can ask. Let's go through each of these 6 components. First, we have reasoning. That is analyze, evaluate, explain, infer, generalize, deduce, and reach conclusions. These are the sort of directive verbs which they will leave us with when giving a question. What does it mean to analyze in maths? Well, similar to how analysis in other subjects is to say the effect of something, in maths we are looking to investigate a problem and find solutions. Sometimes they will give us guidance, sometimes, especially in the Extension 1 course, they will not. The new syllabus also emphasizes analysis using technology through online mechanisms. Communicating. That is describe, represent, formulate, express and explain mathematical situations, concepts, methods, and solutions to problems using a variety of presentations utilizing appropriate language, notation, or diagrams. This is a major aspect of the syllabus. Again, we can fall back to technology, but this also applies into how we respond to questions in written exams. Communicating is not only about what we write, it's also about how we write it. It's about having neat working so that the marker can see what we're doing. Sometimes in your solutions you will also be able to couple your working with diagrams or even annotate what they've given us. Fluency. Recall factual knowledge and concepts, and select and apply appropriate features flexibly, accurately, and efficiently. The fluency aspect in mathematics is just like to be fluent with a language. That is, it is how well you know the content and how well you can apply it in your mathematics to answer the question. In order to become fluent in maths, you need to first get a good grasp of the content, but then consolidate and enhance your knowledge through practice problems and discussion. This is something which we will be emphasizing in our lessons. Understanding. Make connections between experiences and related concepts, and progressively expand and develop ideas. So this is building upon fluency, where we will look to combine multiple topics in our solutions. For example, you might have a question on vectors, but you will need to apply your knowledge of trigonometric equations in order to solve it. This notion of combining topics into one question is something which is not unfamiliar in the mathematics courses, as commonly you will find the most difficult questions in the paper are the ones where it's not immediately obvious how to address them. This also demonstrates that all aspects of mathematics are intertwined, and by knowing one part well, it will help with all parts. Justification. Justify strategies and strategic thinking used, conclusions reached, and explain the reasonableness of findings, proving results where appropriate. Well, the obvious example of this in the Extension 1 course is the proof by induction topic. However, there is an underlying theme of justification throughout all of mathematics. Whenever we are making a solution, we are always justifying our working through steps to get to our solution. For instance, you will never go straight from the question to your answer. You will always need to set a plan, most of the time by muscle memory, in order to get to your solution. This plan will be effectuated through working. Problem solving. Interpret, formulate, investigate, model and solve problems using mathematics in simple and complex, familiar and unfamiliar situations. This is how we address questions. As I said, you will need to structure plans, and this can either be internally in your mind, or maybe you want to jot down some notes as to how you would find the solution, similar to how you plan out an essay in something like English. Your problem-solving ability will be tested throughout the exam, as there is a breadth of questions on a scale which begins from simple at the start of the exam to complex at the end of the exam. The ending questions will most likely be more unfamiliar and will test all your 6 aspects of working mathematically. Here we have the course structure and requirements for the Year 11 component of the Extension 1 Mathematics course. As you can see, it is divided into 4 topics: functions, trigonometric functions, calculus, and combinatorics. Together, these make up 6 subtopics. I would like to pay attention to this point here, that the Mathematics Advanced Year 11 course should be taught prior or concurrently to this course. So if you want to do well in the Extension 1 course, you will need to know your content from the Advanced course. I will talk about this a bit more later with the Year 12 course structure. And while you may think that the Year 11 course is inconsequential as you never get tested on it, this is in fact incorrect. You will find when we examine the 2020 Maths Extension 1 paper that a substantial amount of the exam did comprise of this Year 11 content. Furthermore, although it is not necessarily explicitly tested, these topics lay the groundwork for the rest of the Year 12 content. In further work of functions, we will look at graphical relationships, so this will include understanding and graphing the reciprocal, square roots, absolute value functions of both the y and the x values, and also addition and multiplication of ordinates. And we will use these graphical relationships to solve problems. Then we will move to inequalities. You have already done some basic work with inequalities, but in Year 11 we will work on absolute value inequalities and fractions, among other problems. We will then move to inverse functions, which is essentially when the x and the y values are swapped, before looking at the parametric form of a function or relation, where we split it up into 2 parametric equations. You will notice in my overview videos that I will have a ranking system out of 10 in terms of the difficulty of each topic. Further functions is a 5 out of 10 on my ranking. The second part of functions is polynomials. In this subtopic, we will be looking at the behavior of polynomials. Those are expressions with powers of x or any other variable. And then we will be looking at the remainder and factor theorems, as well as the sums and products of roots. These are all techniques to find the zeros or the solutions of a polynomial. I would rate the polynomials subtopic as a 5 out of 10 for difficulty. The trigonometric functions topic is also split into 2 subtopics. First, we have inverse trigonometric functions. These are functions such as inverse sine, inverse cos, and inverse tan. We will be looking at the domain and range of these relations in order for them to be functions. We will then be looking at the different types of trigonometric functions. We will then be able to classify trigonometric functions, and finally graph them and solve problems with them. I would rate the inverse trigonometric functions topic as a 5 out of 10 for difficulty. The other part of trigonometric functions is further trigonometric identities. Here we will be looking at many of the identities which you find on the reference sheet. These include the sums to products and products to sums of trigonometric functions, the double angle formulae, and the t formulae. I would rate further trigonometric identities as a 5 out of 10 for difficulty. We will also do further work on calculus, which you would have begun in the advanced course. We will begin by looking at rates of change with respect to time. We will begin with displacement and then go into velocity and acceleration. This will allow us to examine exponential growth and decay, which has applicable real-world applications to population growth, radioactive decay, and depreciation in finance. And then we will be able to apply all of this to look at related rates of change. The rates of change topic is an 8 out of 10 for difficulty. The final topic is the Combinatorics topic. We will begin by looking at permutations and combinations. This allows us to figure out the number of ways something can be arranged, either with distinct or non-distinct positions. We will then look at the pigeonhole principle, which is another method of finding how many ways we can organize things, before looking at the binomial expansion. You would have already looked at Pascal's triangle in younger years, but here we will look at an application, the binomial expansion, which has further applications in Year 12. I would rate the Combinatorics topic as a 10 out of 10 for difficulty. Here we have the outline of the Year 12 Extension 1 Mathematics course. As you can see, we have 5 topics: proof, vectors, trigonometric functions, calculus, and statistical analysis. As you can see here, the Mathematics Advanced Year 11 course is a prerequisite. Additionally, you will need to know the content from the Mathematics Advanced Year 12 course and the Mathematics Extension 1 Year 11 course in order to succeed in the Extension 1 Year 12 course. While we are paying attention to this, I will just emphasize the importance of knowing your Year 11 and your advanced content in the Extension 1 course. Quite often the questions which catch out the best students are not the ones which test the hardest Year 12 course, but sometimes the more simple Year 11 content which you wouldn't expect to be assessed on. In saying this, I want you to pay close revision to the Year 11 and Advanced Year 12 content in your study of Extension 1. Not only will it help you better prepare for the test, but it will also enhance your understanding of mathematics. Going through each of the topics, the first topic is proof. The proof topic contains proof by mathematical induction. We will go through summation proofs, divisibilities, and also false proofs. The proof topic is quite unique in that there is no prior knowledge from the Mathematics Advanced course which is needed to study it. On my scale of difficulty, I would rate proof by mathematical induction as a 6 out of 10. The vectors topic contains an introduction to vectors. We will learn about what a vector is as opposed to a scalar. We will learn different forms of vectors and how to add them together and subtract them. We will also then use our knowledge of vectors to do dot products and find if vectors are parallel or perpendicular. In our study of vectors, we will be sticking strictly to the two-dimensional plane. And then we will also be able to use our vectors to do projectile motion. Projectile motion is perhaps the most fun component of the Extension 1 course, as it is very applicable to the real world. Those of you studying physics will also do projectile motion in your physics course. I would rate the introduction to vectors as a 6 out of 10 for difficulty. The third topic is trigonometric functions. This is building on our work with trigonometry from Year 11. We will look at the auxiliary angles, the t formulae, and proving some identities. These will allow us to solve trigonometric equations in a variety of contexts. I think that the trigonometric equations topic is the most easy to tie in with any of the other topics, and therefore it is most likely to be in one of those high mark questions, which contains multiple topics. I would rate the trigonometric equations topic as a 7 out of 10 for difficulty. The calculus topic is divided into 2 subtopics. First, we have further calculus skills. So in the advanced course, you will continue doing differentiation, but then you will also introduce integration. That is the reverse process of differentiation. In the Extension 1 course, we will look at harder integrals and derivatives, and look at some methods to solve integrals which you wouldn't do in the advanced course. The further calculus skills is building upon the work of calculus you do in Year 11 and in the advanced course. We will be learning new methods of how to solve harder integrals, which will tie into the applications of calculus. I would rate the further calculus skills as a 6 out of 10 for difficulty. The applications of calculus builds further upon the further calculus skills. We will learn how to calculate further area, such as the area between curves, but also the volume of a solid of revolution. That is when a curve is rotated around the x or y axis. We will also be looking at differential equations. These include slope fields, derivatives, and integrals, and ultimately build to exponential growth and decay, which have very real applications to the real world, as we see here in chemistry, biology, and economics, among other things. I would rate the applications of calculus as a 6 out of 10 for difficulty. The final topic is statistical analysis. This can be seen as a progression to the probability topics, which you would have already studied. Our focus here is the binomial distribution. So you would have done binomial expansion in year 11. Well, the binomial statistical analysis is an application of this, as we see it done in this formula here. I find the statistical analysis using the binomial method as quite interesting, because we can look at the probability of some real-life occurrences, such as simply rolling a dice and getting an even number. But we also go further to get some more complex scenarios. We will be able to look further upon our understanding of the mean and variance, and then go into normal approximation for sample proportion. This is quite interesting because this is actually how the ATAR is calculated, because everyone is put on a normal scale. This is something which we'll get into later in the course. I rate the binomial distribution as a 5 out of 10 for difficulty. The final component is the glossary. This gives some definitions of the terms used in the syllabus. I wouldn't pay too much attention to this either, because we will be learning all of this content in our study. To end the video, I will give a brief overview of the HSC 2020 paper for Mathematics Extension 1. As you know, for Extension 1 the paper is 2 hours. That is 1 hour less than most of your 2-unit subjects. And you were also given 10 minutes of reading time. The total marks is 70 for the test. This includes 10 multiple choice questions. Throughout your study in the Mathematics Extension 1 course, I recommend that you continually refer back to the 2020 Extension 1 paper, or in subsequent years the most recent HSC paper, as well as the NESA sample paper for Extension 1. These both give a good indication into the difficulty and range of questions which will be asked in the Extension 1 exams. Looking at the 2020 paper, it was divided into topics as follows. Vectors comprised 6 marks, trigonometry was 11 marks, statistics was 3 marks, proof was 3 marks, calculus was 27 marks, functions, a year 11 topic, was 9 marks, and combinatorics, another year 11 topic, was 11 marks. As you can see, the paper had a large composition of year 11 topics, which added up to a total of 20 of the 70 marks. So this echoes my statement earlier, where I emphasized the importance of consolidating the year 11 work heading into the year 12 exams. Given that this is the first exam of the new syllabus, it gives a good indication of how the future papers will be. Therefore, you can assume with some confidence that the following year's papers will have a similar ratio of 50 marks on year 12 topics to 20 marks of year 11 topics. With this being said, thank you for watching the video, and I'll see you in the next lesson where we begin vectors in the Extension 1 Year 12 course.